Hello everyone, in this video we will solve GATE 2022 ME Set 1 question number 24. This question is from the topic fluid mechanics and the question is a tiny temperature probe is fully immersed in a flowing fluid and is moving with zero relative velocity with respect to the fluid. The velocity field in the fluid is vector v, which is 2x I cap plus y plus 3t j cap, and the temperature field in the fluid is the scalar temperature T is 2x squared plus xy plus 4t, where x and y are the spatial coordinates and t is the time. The time rate of change of temperature recorded by the probe at x is equal to 1, y is equal to 1, and t is equal to 1 is. The options are 4, 0, 18, and 14. So let's now look at the theory we need to solve this question. We need to know what the rate of change of a scalar field, which is also called as the material derivative of that field in a 2D flow field given by this vector v is. So that material derivative is given by this formula. So here this is the material derivative or the rate of change of scalar t. So t is some scalar which varies in x, y as well as time t. And it has two components. This component is the partial derivative of the scalar t with respect to time and is called as the local term. The second term is called as the advective term, and this gives you the advection of the scalar field when it is under some kind of a fluid flow given by this vector v, velocity vector v, which is u I j cap plus v j cap. Now, knowing this, let's see how we can solve this question. So we have been given the velocity field v, which is 2x I cap plus y plus 3t j cap. This means that u is 2x and the v velocity is y plus 3t. Also, we have been given the scalar field T, which is temperature, as a function of x, y, and t. And this is given as 2x squared plus xy plus 4t. Now we need to calculate the time rate of change of temperature. So from the last slide, we know that that is the material derivative of temperature and is given by this formula. The local term and the advective term. Now let's put all these terms there. So partial t with time is nothing but 4 plus u is given as 2x and partial t partial x is given by 4x plus y. Similarly, v is 4 plus 3t and partial t partial y is given as simply x. So this is the material derivative of t. Now we have to find the rate of change at this location and at this time. So let's substitute x is equal to 1, y is equal to 1 and t is equal to 1. Then the rate of change of temperature will be 4 plus 2 times 1 plus 4 plus 1 plus 1 plus 3 times 1. So this is nothing but 4 plus 10 plus 4, which is 18, and that is the answer to this problem. So the answer to this problem is option C, 18. And in order to know more about this topic, you can refer to this NPTEL course video Introduction to Fluid Mechanics and Lecture 23 by Professor Suman Chakravarti of IIT Kharagpur.